Okay, so let me just summarize what we did so far. So, just to put everything in perspective and give some kind of some tips. So, what all did we cover? CPU, parallel machine. So, this was hardware, no? But I believe, I hope you agree that hardware was important component. Without knowing the hardware, we could not have understood why OpenMP, why MPI, how to use GPU, what is shared memory, so cache, and then we went to software. So, this is for multi-core, which was the paradigm till last couple of years. So, most of the parallel programming was on multi-core systems, but things have changed of late. There are of course many people or many machines which use multi-core now, even now, but there is a huge shift towards GPU at the present. So, so this also, so with Python also we can, is part of multi-core, but with the GPU we have CUDA, OpenACC, CUPA and NUMBA. There are some more which I did not cover. I mean OpenMP also you can use GPU, and this is called OpenCL. One problem which is going to come, which is already coming, is that CUDA is GPU of CUDA works in NVIDIA's GPUs, but there are other marketplace. No, AMD is making good GPUs. Intel is coming up with a new GPU which is not in the market yet, but there is a new GPU, and there will be more people. Now, CUDA is a closed source. You can't, I mean the AMD cannot, CUDA is NVIDIA's. So, AMD has its own, Intel has its own. Now, this is a problem for a programmer. If you write a code for NVIDIA, then it does not work on AMD GPU. So, that is a standardization problem. The MPI, this has been solved. So, whether you work with Intel machine or AMD machine or some Japanese chip, or so all of them will support MPI. MPI is standard syntax, it is hardware independent. Same with OpenMP, Python, these are all hardware independent, but these are not hardware independent. CUDA is not hardware independent. OpenACC is, I suppose OpenACC will be supported by all GPUs, but then it is not, OpenACC does not give as good performance as CUDA, in fact much weaker performance typically. So, that is a challenge, and I am sure it will be resolved soon. So, there will be a standard GPU language which will be which every party should agree on, but right now NVIDIA is quite ahead in this game. So, anyway, this is a present challenge, but this should be sorted out in maybe 5 years, but we can't wait for this to be sorted out, we have to use. So, there are ways to run CUDA code on AMD machine. So, AMD also has to right now give some compatibility. So, this is called HIP. I am not run it on AMD, like you see in Colab is basically in NVIDIA GPUs. So, opportunities, I believe present computers are very fast and is getting faster. So, you get better and better machines. So, it is not that it is saturating now. So, there are people coming with clever schemes to pack more transistors, even though we are reaching a quantum millimeter. So, 2 nanometer technology is basically hydrogen atom is electron is something like 1 angstrom. So, we are getting 20 times the electron distance in hydrogen atom, or bigger molecules are size of a nanometer. So, silicon I do not know the radius, but we are close to the atomic dimensions. Even then people are able to get very good I mean pack stuff, transistors. And there are more avenues which are coming up. I mean people are trying to layer up layered transistors in a chip. The memory, there is a 3D chip, no, the 3D memory, high density memory called HMI, I think HMI. Yeah, so things are getting more and more advanced, and so more and more opportunities. So you can solve problems that we never have imagined, like in turbulence. We are able to do things which 20 years ago nobody thought that it could be done. So galaxy, black holes, stars, planets. Weather predictions are quite accurate, not in India, but abroad there are people say that is 1 hour is going to rain, rains in 1 hour. Drug, medicine system, social network, automatic cars, this is big. Robots are going to come at homes. Okay. And in fundamental physics too, there are chemistry, biology, like brain, there are people trying to solve brain with as many neurons as in the brain. Okay. So more to come. I think faster hardware is coming more and more. Okay. Better programming tools. So better means I don't mean to say it's easier, but you can get more power out of the machine. So the GPU stuff is new, and this I mean CUDA is definitely is not only syntax. Actually, syntax is the easy part. You have to think differently. Quantum, you need to think very differently. Okay, and this is another thing which I am not as gun ho as many people. AI and data science. Okay. So it's true, it has a lot of power. So we can do things in science and marketing, in all sorts, agriculture, weather forecast. Weather forecast, I don't know, anyone was there in the talk? Well, a week ago, 30th. So weather forecast using AI is as good as what you get from differential equations. Okay, so presently AI has reached that kind of sophistication. Okay, so this is a interesting thing, but will AI replace us? I mean, you say we don't need. Well, I mean, you want to construct theory. Some people think that they can construct Newton's laws. I don't believe so, but okay. So will it be? I mean, it is basically a machine which can work with large data and come up with fits, predictions. But anyway, this is a also philosophical challenge. I mean, there is a, and also your life. I mean, I think with data, people are going to control others, which is already being controlled. Elections are being controlled by AI. Okay. Mind is with all this videos coming on the Facebook is control. Okay. Quantum computation, I think it's you should well, I don't know much about it. I know little bit. You wanted some lecture on it, but we couldn't. But anyway, it's an interesting paradigm. I think it will become a reality. It's already reality, but it probably get in more in 5 years. But I think the classical computation will continue. It could be combined with quantum, but for example, fluid solvers. So FFT, there is a quantum FFT is available. Okay, we worked with quantum FFT. But if you want to multiply two arrays, U1 into U2 or U squared, then you face difficulty. Why? Because I want to. So U will be the amplitudes of the wave function. No? So it's very interesting. Psi is a wave function. You write for spin half particle, you write C0 up spin plus C1 down spin. Right. So this is my state. So we have two numbers C0 and C1. So, we have for every qubit we have 2 of them C 0 C 1, which is in fact a real number, a complex number. Okay. So, if I want 8 numbers, so this will be numbers basically for 8 numbers. How many qubits do I need? No, I need 3 qubits. So, I have 3 qubits, then I will have what are the options? 0 0 0, 0 0 1, 0 1 0. So, the 8 options, and every option will have coefficients, right. So, for 3 qubits I will write my states like that, right. So, I will have C 1, C 2 like this. So, C 7 1 1 1. So, with 3 qubits I can get 7 states. With 8 qubits how many states can you get? 2 power 8. So, I can work with, I take 8 qubits and I can do Fourier transform of 2 to the power 8 numbers, which is 512, right, 256. So, it is also growing exponentially. So, with 10 you can go to 1024 and it is exponential. So, you can get bigger and bigger numbers. Now, this algorithm exists. The problem is when I do quantum computation, yes.
Sir, bits also, like you keep adding them like go up exponentially.
Bits what?
Bits, digital bits 0 1. Like
No, these are not digital bits. These are qubits. These are spin half systems in a quantum system.
Yes, sir. I'm saying like the behavior you are telling about right now is like is it not the same as the digital bit?
No. Digital bit is either 0, fixed 0 or fixed 1. Here it is superposition of 0 and 1. Okay, when I make a measurement, then I will go to 0, or when I make a measurement I will go to 1, but in between it is mixed. So, my state will be mix of this combination. So, it is living in 8 dimensional space and it is going around. So, the evolution is done by the dynamics. So, quantum FFT is operating on the dynamics, it is taking this turning around like that. So, initial condition is 1 you give, but then the C zeros will have real numbers in the beginning, well real space, but then after that it is going to be in Fourier space. So, one problem is, major problem is that when I make the measurement, how do I get the Fourier transform? I need to make the measurement, right. So, I will get C 0 mod square, C 1 mod square like this, and from that I derive what is C 1 quite well, take a square root, but if C 1 is complex then I cannot take a square root, and moreover I need to do lot of sampling, right. So, the C 1 will be having a fluctuations when I do the measurement. If this quantum state C 0, C 0 1 and C 1 C 0 0, C 1 1, then when I make a measurements I do not get C 0 exact, okay, probability will come, and from there I need to deduce what was C 0. So, I need to do lot of measurements and the distribution, from that you derive. So, this is another big problem, error, it is called error correction or something, okay. So, it is not all that straightforward, you get something and you are able to get the result right away.
Sir, so qubits actually take continuous values from 0 to 1 and there is some probability of taking it.
C 0 is an amplitude which you feed in the beginning. So, all this C 1, C 0, C 7 you can put a real number, complex number. So, this is a preparation of initial state, then it evolves, then it goes to C 0 prime, C 1 prime, C 2 prime at a time t, but it is the quantum state. So, how do I get C 0 prime? I cannot read it, no, you need to make a measurement and get mod C 0 squared with the distribution. From there you need to figure out what C 0 is. Okay, that is a error problem, error correction problem. Second is I need to multiply my classical arrays, no, I mean classical fields U squared. Now, we face this problem when we try to, well, let us try to do fluid simulation. The U squared I need to copy U, right, and multiply. So, copying is not allowed in quantum computers. So, this is called anti-cloning theorem. So, no, you can't clone a quantum state. So, I cannot get exact u, you can get approximate u. So, or you can come to classical for multiplication, okay. That is another hybrid calculation. Some you do in quantum, some you do in classical. So, it is not, I mean, we are not, I do not know whether you can really do all the work which you do in classical in quantum, not possible, I believe. Okay. So, these are the challenges, computation challenges. There are technical challenges, and philosophical challenges, theoretical challenges, all that is different. Hardware, so multi-core and GPU. So, this is I believe is a major thing right now, but whether tomorrow something else may come. So, nobody expected GPU to make such a difference, but it is there now. So, it is I think very fast system right now. So, there are reasons why it is fast, and I like my example, the Rambo versus square army or army pattern. Okay. So, that is a good example, and the accelerator is also green. Now, you might have read about one new news. So, Apple came with this M1 chip, right. So, all this, whether all your mobiles are ARM processor based chips. Now, I did cover a bit of this stuff, what is ARM, right. So, they are different CISC architecture versus RISC architecture. Okay. So, they are different architecture, and Apple is able to get a lot of. So, why people use this ARM processor in a GPU in mobile is because it is less energy consuming. The instructions, it has advantages, also disadvantages. In one clock cycle you can't do much compared to CISC. So, but now all these companies are like Qualcomm, AMD, they want to make chips with ARM. Okay. So, ARM based chips will come in your laptops, non Apple as well. So, I think they will pack a lot of cores in a GPU and a CPU with ARM processors. So, I think that is another thing which is coming soon, but I think GPU cannot be taken away. I mean, this is something will stay for a while. Okay. So, this is another thing which well okay, so presently when you make a system, you have CPU, you buy separately, okay, Intel, AMD. Then we have memory which is separate, and there is a motherboard on which it all goes, and if you are making parallel machine, then there are interconnects, okay, interconnect which will connect all this. So, they are typically sometimes they are not compatible or they are not optimized. So, if it is optimized for CPU, but not for GPU, not for memories, or actually GPU also, you should put GPU now. So, you can get NVIDIA card and you can put on a motherboard, but motherboard is not made by NVIDIA. So, now NVIDIA is saying that we will make optimum system with all our CPU, our GPU and our switch. Okay. So, NVIDIA is coming up with its own CPU, and the switch they bought InfiniBand. Okay. InfiniBand is now owned by NVIDIA. So, these are good. So, Apple, one thing is that their software and hardware are tightly coupled. So, the software is making use of lot of their hardware, and most of it is closed, right. Other people can't know what is inside. Okay. And software, well, few things I did not cover. Okay. This C++17. So, it turns out we can do parallel computing with in C++17. You do not need to do OpenACC, it has its own framework of coherence and concurrency and so on. This is a major new features of C++. So, keep an eye for it. I mean, this is definitely worth looking at it. Okay. So, we covered quite a bit, but well, I did not, this is AI stuff. Okay. but the AI uses different parts of the GPU. So, there are tensor cores, I did mention the tensor cores, it is meant for AI and they are faster than the other cores of NVIDIA of the GPU. So, tensor cores can do maybe 8-bit operations or 16-bit operations, and they can do something like 10 or 15 operations per second. Okay. These are hugely fast, because there are also number of bits is less and they are optimized for some operations like this convolution operation can be done very fast in TensorFlow. So, computer languages, I think C, C++ you should know if you want to become a very good programmer. Fortran I do not know, Fortran would not keep up with this stuff and maybe it will become obsolete. So, this is part of C++ 17. And actually with CUDA now, well, I was thinking that Python we can manage alone with Python, but with CUDA you need C. Right. So, C is required. So, I would say Python and C both we should know, and one thing which I did not do in the course is class. So, classes are very useful, okay, for large codes. So, classes are there in C++, not in C. So, that is why C++ has more features which are very useful for big codes. So, these are languages I do not know myself, but right now they are not competition, I believe Julia, Rust, Go, but maybe we do not know, tomorrow some new things can come. So, my recommendation is learn GPU programming, learn C, C++ and Python. Okay, so program regularly, I think that is one is without you lose touch, okay, that bigger teams, I think you should work in team. I hope you well, maybe you are doing it before, I mean there are a lot of activities, Antaragni, people work in team, but code development is teamwork is essential. Whether it is also not necessary that you do the coding only. So, somebody codes and you can use that code and help out, you know. So, testing is a very important component, okay, and you can if you want you can kind of volunteer for our group. I think I am sure you will learn something from that effort. It is not, of course, we will gain from your volunteerism, but you can also gain some experience and keep learning. Okay. So, this is something which is not only for programming, but keep yourself young. Okay. Neurons should be active, otherwise they will become dull. Okay. Good luck.